Well, good morning, everybody, and welcome. Thank you for coming out. I think we're going to have an interesting discussion here today, talking about EV conversions and obviously a new and emerging market, but I think it's a very interesting space. And anytime you've got something that's as brand new as this, it certainly leaves a lot of opportunities for people that want to get involved in it. We've got, a very diverse panel up here. Some interesting guys that have got a lot of experience in this. For those of you who don't know me, my name's Alan Reinhart. I'm the announcer for the National Hot Rod Association, but I am not here in any capacity for NHRA today. I'm just sitting in and going to try to be the referee, and we'll juggle it with the four gentlemen that we have up here. Let me introduce you to first Jake Hawksworth, who's a fabricator, designer, engineer, and founder of Hypercraft. Tell us a little bit about how you got involved and how you got started and where we're at right now.
Yeah, thanks for having me here. So I did about 15 years in motorsports, power sports as a design engineer, working on chassis suspension. So I got involved in EV through a vehicle project that we were looking for new propulsion technologies, and just got interested in kind of the flexibility of EV from a space claim and how it fit into the vehicle platform, how we could redesign the suspension, all of the vehicle dynamics being new. And just kind of caught the EV bug and wanted to know a little bit more about the propulsion technology side of it, and that's kind of how Hypercraft started. So,
thank you for being here today. We also have Kirk Miller is here. Kirk spent 20 plus years at AEM, and I think cutting edge of electronic controls and converters and everything that's needed to make the kind of power and do what we do now. Now independently consulting. Tell us a little bit about your background and tell us a little bit about where you're looking to go from here.
Sure, thanks. As you said, 20 plus years at AEM Electronics and AEM EV. Background is race car family, had my own company at a young age, tuner, fabricator, and went on to join AEM back in the late 90s. How we got into EV is when, where we're located in Southern California, there's a lot of boutique OEMs, conversion facilities. And they started using our race display dash, which is cam-based, as a logger mechanism and display. And as a result of that, we started looking at the market and realized that it's very similar to the tuner market in the late 80s. A lot of people, incredibly bright people, building incredibly amazing cars, but the lack of a single control unit or supervisor unit, or we refer to as an adult in the room, meaning a controller unit, it was lacking. So we saw some opportunities to bring some discipline to the builds and also some safety that we thought was lacking in that environment. Back in September, I departed from AEM/Holley, and now, as mentioned, I'm an independent contractor. I'll start by saying I'm a motorhead. I'm a petrol head. I've got 9 motorcycles, 2 boats, 4 cars, just way too much of everything. And I'm a racer. And there's a lot of speculation about the EV segment, but it's undeniably coming. Some of the visibility that I've had as a result of my position within AEM and in the field, it's really, truly fascinating, the uptick in interest, meaning demand. So we work with a lot of builders, very high-end builders that you would know at the show. In certain regions of the country, they're seeing up to 50% of the inquiries of the builds to be EV versus ICE, internal combustion engine builds. So these are indicators of not necessarily a complete change or departure from ICE, but to me, the most exciting component about this is a brand new market segment that is at its infancy, and it's just going to continue to grow. So I see an incredible long on-ramp into this market segment. The OEMs are obviously embracing it. The younger generation, to a great degree, are embracing it because of the technology and the green factor. I'm not going to speak for everyone, but I can guarantee nobody's up here to talk about it being green. It's fun, it's fast, it's amazing. It's also incredibly complex, which we'll probably get into, and dangerous when you're talking about direct drive systems. You can't throw a clutch in, throw it in neutral or park. If something goes south on a direct drive, you're in trouble. So Where am I going? I'm going to try to drive this train as best I can so we can create this new market segment, but try to do it in a manner that does drag the safety along with it so we can all have fun and see the results that we're anticipating.
Thank you for taking time out today. We've also got Maverick Knowles here, who is a co-founder and president of Legacy EV, honoring the past and protecting the future. How did you get started in EV? And tell us a little bit about your background, your company.
Yeah, thank you. So Legacy EV was founded conceptually back in 2017 by Rob Ward, who's my business partner. He had the idea. He's been a lifelong gearhead and rode a Tesla P100D and was like, oh wait, these things perform. Like there's something here that's fun and different. And so he caught the EV bug, like you're gonna hear from everybody else up here. And we started looking into the market and really taking a look at what did the market need. And we found a niche in parts distribution. We figured that there's a lot of people manufacturing really great parts, but we need to integrate those together to make sure that we can get complete running systems that builders can now go install. And so that's what Legacy EV does. We're a systems integrator. We work with like 60 different manufacturers now to integrate complete kits that you can take and install into your build. And my personal background's in education, so I was a math teacher at a STEM and robotics school, project-based learning, and so I love taking complex concepts and trying to make them accessible to more people. And so that's the other thing that we're doing in the EV space. We're taking the kits and integrating them, trying to make it simpler to get the products you need, and then trying to make all the knowledge accessible as well.
I would think the math background would be big in something like this because there's obviously a lot of calculations, a lot of things you're working out to make this all work, right?
Yeah, definitely. My team's got to check me on how much math I try and put into the education. We've got a lot of calculators nowadays that can calculate your final drive ratio. You don't necessarily need to know how to run all the formulas yourself, and so they check me when I start making people actually get out their calculators and do the formulas themselves.
Every time somebody talks about being a math teacher, I remember my teacher telling me, you need to learn this stuff. You're not going to have a calculator in your pocket your whole life. Tim Chamberlain, also here from Legacy. Tell us a little bit about you, your background, how you got involved, and where you're at.
Yeah, so my background's in industrial automation, and so I've known Maverick for a long time, and we ran into each other a couple of years ago now. I was very excited about what they were doing. I also saw the potential. I'm also I like to go fast, and so you see this. For me, getting into it, I saw. Okay, my background in industrial automation, controls, motor controls, communications, and then also see this intersection of something else I really like, which is cars and speed and motorcycles. And so I joined initially doing a lot of the more technical aspects, so wiring and building the vehicles, and now I've transitioned more into like a business development sales role.
All right, well, everybody's mentioned a little bit about performance, and I think that a lot of ICE purists, if you will, look at electric cars and kind of want to throw rocks at them. But is that one of the big selling points when you're trying to tell somebody to take maybe a classic and move it over? Is like, look, you can have the performance without all of the extra issues, without all of the extra trouble? I mean, Jake, if somebody comes to you, I just bought a 70 Barracuda, it's going to be a project car. I have no idea what I'm going to do with it. If I come to you and say, okay, I'm looking at various options, sell me on EV. Why should I go your way?
Yeah, I mean, I think where we're at today in the industry is going to be different than the answer I'd give 5 years from now, right? Because there is a lot of complexity to EV today. There is a lot to learn. There's a lot that we're inventing. And we're trying to do it in a very, very safe way. So what I would say is what's going to attract people to EV today are the people that want the challenge, that are interested in the new technology, are looking for that next thing to push things forward and get excited about. And that's where I would start with that conversation, because once you make the choice to be an EV, there are so many exciting things, and performance is being redefined. I mean, we have cars now that are not just fast in the sense that they go 0 to 60 in 1.4 seconds, but they do it incredibly intelligently, right? For motor control, torque vectoring, all these new technologies that we're seeing, and everything's driven by software. So for a Barracuda, for a simpler conversion, there's a lot of ways to jump into that, but there's still a lot of education, and that's what guys like Legacy are doing a great job at. Hypercraft has more of a higher level technology integration for race teams that want to push the limits. And we have a kind of a dedicated racing division to our company, and some really cool programs. One of those being Scalar, which is here down in the EV performance segment. But it really has to be. We step into it very carefully. There's a lot of conversations about safety, technology, where it's really at today. It is coming, and it is very exciting. But you have to be willing to take on those challenges.
Now, is there a big difference, and whoever wants to jump in, with the actual components about building a performance street car versus building a race car? Are we talking about two completely different things, or are we talking about something that you could almost hybrid?
Well, from the control standpoint, that's what AEM specialized in, is that there's a difference in the control strategies. So in racing, cooling, thermal loads, the battery itself, there's something called a C rating on a battery, and that's basically how fast it can discharge, the actual capacity of it to dump current or energy. So if it's a hardcore performance car, you want incredibly aggressive acceleration like a drag car, you're going to have a high C rating. If you have a street car that's a performance-based vehicle, but just street driving more, you can have a lower C rating. What that means also is that your costs come down with a lower C rating. So the higher the C rating, you're going to accelerate your cost dramatically. In addition to that, your powertrain, your drivetrain, the drivetrains are pretty amazingly flexible. You can have a very powerful motor drive system or propulsion system and detune it to a degree, and then have it run at a higher efficiency rate for longer periods of time. So now you're talking about range. That's kind of a convoluted response, because the biggest, I would say the biggest variance is going to be the battery pack, in your energy system. But the components themselves, you're just going to size them to what your needs are. So if you want 1,000 horsepower, you put 1,000 horsepower motor set in, or kilowatt pack in, or motor set in. And then you're talking about additional enhanced features. Jake just touched on, when you're talking about torque vectoring and things like that, that's a much higher degree of complexity in the setup. So again, to Jake's point, as systems over the next couple of years, you're going to have more plug and play base cals that are going to accommodate this with drop-down wizards in your calibration interface, versus today, a complete set of strategies have to be worked out for that, and then integrate it in a unique firmware pack for a rock crawler or a road car or a drag car or whatever it might be. So from the control strategy and the development standpoint, if your customer says, I want a race car with vectoring and high current discharge and all sorts of horsepower, that's going to be a very, very expensive, complex build. If they say, I want my street car, convert it, I'd like to go light to light and have fun with it, but I still want climate control and, traction control, rate of acceleration, things like that, that's a much easier build to present. And in the end, going back to your vehicle, I just want to touch on the experience that I've had with conversion shops and listening to the customers talk about the car that they want to buy. A lot of the people doing conversions right now, it's an expensive, challenging decision. Typically, what I'm seeing in a lot of cases, and I'm sure the vehicles you've seen, are either full-blown race cars, like Huff's drag car or the Scalar vehicle, or some super high-end build like the Bronco that you guys have done. And these are cars that are $150,000, $200,000, $500,000. That's not realistic. We're not going to build an industry or market segment on that. But when you hear the guy say, when I was a kid, I wanted a 2002 so bad, or I wanted this, or I want just some old sports car. Now, you're locked into this ideal, so this person standing there saying, I want this car, me and my wife, we're going to go out on Sunday cruises, it's going to be so cool. The reality is, it's underpowered, it's underbraked, it's carbureted, it's got a choke lever, there's a good chance you're not going to enjoy the exhaust note or the oil drips on the ground, and it's going to be an underwhelming experience. An EV conversion literally flips that. You now take a vehicle, especially on the Volkswagen side, where you have something that's 35 or 40 horsepower and you need 19 seconds to go 48 miles an hour. You can put we've worked with a lot of these shops where they have just a Hyper 9, a low voltage system, 100 volt, 90, 92, 98, and they're now 120 horsepower. That's awesome. You've just tripled the horsepower. So guess what? When you get in the car, you push the button, it's still quiet, so there's no exhaust sound, there's no exhaust sound. You're not waiting for anything to warm up. When you drive the car, it's an enjoyable experience. It's no longer underwhelming. I've taken people for rides in Volkswagen buses that are converted with Hyper 9s, and their heads unscrew, because it literally goes. So it makes the whole conversion opportunity substantially more enjoyable, and it literally becomes that ideal. And there's a value for that. And again, to everybody's point up here, there's going to be plug-and-play packages that are going to come down the pipeline. The economies of scales are going to follow, just like everything else, and it's going to drop down. When I say everything else, I mean historically, all of us have seen this industry long enough to remember what early EFI systems cost. Even from AEM's perspective, a wideband controller used to be $1,800. We're now selling them retail for $141. So then that's over the course of 10. It was 4 years before we got the price down. So these things are all going to come into this market as well. So long-winded response.
Maverick, you look like you wanted to jump into that.
Yeah, and I was going to actually jump back to your first question too real quick, which is just like why would somebody convert? And I think I have two general responses to this. Like one, I think Jake said it really well. Like 5 years from now, our answers will definitely look different. But right now, most people who are doing conversions can consider themselves a pioneer. You're doing something that not many people have done. And when you take a car to a show, you're going to get eyes on it. You're going to get people gathering around it because they want to see something new. They can do burnouts, and it's silent, and it's super cool, and just grabs people's attention, and it's really exciting. And then the second piece that we're seeing in the market is we're getting people interested in classic cars that weren't necessarily interested before because of the ease of use and maintenance. So, somebody who maybe grew up dreaming of driving a classic Bronco, but it's like, man, I have no idea how to drive a classic car. If something happens to the engine, I don't know how to fix it. This is an overwhelming experience, where now if you can get that as an EV, it's like very simple ease of use. So that's more on like the consumer end. That person might not necessarily be like building the car themselves, but if they buy a converted car, now they get to drive a classic and have the ease of maintenance around it.
You touched on something, and whoever wants to jump in here is fine, but a lot of those classic type cars, it's the garage queen, right? It sits there with a battery tender on it for a while, and when you come back, you want to start it, well, the carburetor's leaking, and but with an EV, there's literally, right? When you keep the battery charged, there's no maintenance, there's nothing that you have to worry about going forward, correct?
Yeah, no scheduled maintenance. Right. Stuff happens, and sometimes you got to get in there and fix things, but that's the idea for sure.
Did you want to jump in?
I think that there is a really important element to the cost of participating in motorsport. We have a program going with SCORE and off-road racing, trophy trucks, where you start to look at what it costs to continue to participate in these motorsport activities. And there is a path with EV that makes that much more accessible. As Kirk was saying, as the initial costs to get involved come down of all this new technology, those ongoing maintenance costs. You have 2,000 horse and electric motors on a high performance race vehicle. Those motors are going to be good for 2 to 3 race seasons before they have to be pulled out and rebuilt. That's an incredible difference, compared to the same thing in ICE. So, when we look at the benefits of electric, they're very different than gas. This is not a zero-sum game. I think all of us can say we're all motor heads. I rebuild engines, love high-performance engines, right? So we're not replacing a propulsion technology. We're adding a new propulsion technology, which is an opportunity to be excited about something new and bring in new people. And I totally 100% agree with what Maverick said about the younger generation. Writing code for these EV powertrain systems, high-performance EV powertrain systems, is very, very exciting. And I'm not a software guy, so if I can get excited about it, it kind of means something.
We talked a little bit in one of the seminars yesterday about just how different it is. I'm very mechanical. If something's wrong with something, I can take it apart, I can look, I can fix it, I can put the thing back together. It's just a different mindset, right? That you've got to get in with your computer and with your analytics and to try to determine what's going on in there. But for somebody like, I hate to go a day and not learn a new thing. And the guys yesterday were talking about how consumed you get with it when you get in it and you start learning and you see the technology and you see the next step and then you just keep chasing and chasing. Is that something that kind of sucked you guys in as well?
I mean, it did me. You know, I mean, I was chassis suspension as a mechanical design engineer, and this is the steepest learning curve I've ever had on anything. But it challenged me in a whole new way. And you know, you're designing mechanically the way that current flows through an electric powertrain system. And there are so many challenges with this where we need all of the experience from the motorsport industry, all the guys who have worked on race teams that have been involved in these programs to bring their level of expertise to this. This is not necessarily just the new blood. This is kind of the existing knowledge as well.
Yeah, that's today. And in, like we were saying, in short order, there will be packages and there'll be a range of tuning. If you go down and see the GM package that's downstairs, it's a complete package that can be fabbed up into a vehicle. So the complexities that the pioneers or these early adopters are dealing with, those are always going to be on our shoulders. The majority of that is going to fall off, and for the people who are looking at this as a business opportunity and doing builds and conversions, it's going to be much closer to plug and play. There'll be much less. There shouldn't be any kind of code writing or anything like that at the installer level whatsoever. So it will get easier. So I don't want to scare anyone off with that. Let the challenge be, to the manufacturers or the developers' side. But there's one other thing, Alan, I want to touch on.
Sure.
Something that's really critical in our industry is called the RPM Act. And if you're not familiar, the Clean Air Act of, I think it's 1975, basically says that if you take a vehicle that has emissions controls, was manufactured with emissions controls on it, and turn it into a full-blown race car, meaning cage, no VIN, no plate, no registration, it's got a vehicle logbook, but it was a production car that had emissions compliance on it or devices on it of some sort, that's actually a federal offense. And a lot of people don't realize that. So what's happening right now as a result of some other people playing silly in the performance aftermarket, it's drawn the attention of the EPA. I mentioned, if you're familiar with AEM, I've got a tuner background, small displacement, high-powered vehicles. A lot of these start out as street cars, get turned into race cars. In a lot of cases, they take their street car, turn it into a race car for the weekend, which means downpipe, reflash, different tires, comes back to street life for the daily commute during the week. The fact is, all of that is illegal. So what's happening right now is the EPA is cracking down on dyno facilities across the country, walking in, asking for demand letters to say, what have you done to these vehicles that are newer? So all these newer vehicles where people are doing long tube headers, that's a federal offense. And in California, it's a state offense. We're based in California. So this is an accelerant for me personally, again, to give you a path. If you're a tuner, if you're a builder, and you're doing performance work on vehicles that are altering the emissions output or engine swaps or anything like that, this is a path out. So that's what makes this, again, just another exciting component of this. And it's not a ho-hum path. It's a badass path once we get things organized. And it'll be a lot of fun. So I just wanted to share that point because it's really, there's so many things in the back of my head that I want to share at events like this because, like I said, I'm a cheerleader. I'm a champion for this new segment, and I truly believe in it. But these are some of the driving causes for my enthusiasm, not just the performance, even though that's a big part of it, and the business opportunity.
Tim, let's get you involved in the conversation here a little bit. You're product manager, customer guy. I call. I've got a vehicle. I'm thinking about doing this. Sort of point me in a direction. What would you tell me? Where do I start? What do I do?
Yeah, absolutely. So I think the first thing, and I'm sure a lot of us here are in the industry, own shops, are performance oriented. So kind of the first distinction I like to make is, okay, well, are you a shop taking on a conversion, either self-funded or for a customer, or are you more of a DIY guy? So that's like the first thing we're going to figure out. And so I'll speak to both of those. So if you're a DIY guy, then what we've done is we've taken a lot of the guesswork out of it. We do get, calls from people who bought a bunch of different components. They don't know how they go together. They don't know that they're not compatible with each other. They're like, they pulled out their wallet before they really did all their homework. And it's a lot more exciting to get parts in the mail than it is to to understand something fundamentally. So in that case, if you're going to do it yourself, if I'm speaking to you as a DIYist, then we would get you set up with a full kit. We'd kind of walk you through that decision process so you're not guessing. We're providing education, safety training, those sort of things, with the expectation that it is your DIY project. Now, it's different if you're a shop. So if you're a shop, what we're seeing is there's a lot of shops that are, say, maybe not you, but maybe a shop on your behalf. You've been a long time customer at this place. You decided that you bought a Tesla and that you want your Barracuda to perform like your Tesla did. And so you went to your favorite shop and asked them. So in that case, the shops that are doing this are either A, they've seen the demand, they've seen this request from their customers, or they've seen the writing on the wall. They've seen these promises by companies and governments, and they've seen Ken Block go EV, and they're saying, like, if I don't get moving on this now, if I'm not looking at what this looks like, or even considering it 10 years from now, you're going to be behind. And so in that case, after that point, like with working with a shop, then now we're talking, it's a similar road, but we're to a different audience. So now we're talking, okay, this is the kit for your customer. We're supporting them through that process. We're doing the same education. So it looks different just based on the scale of what you're doing. But yeah, we'd get you set up with parts and smarts and be willing to support you through that process.
From a do-it-yourself standpoint, if I'm putting together something, I can buy the rear end, I can do the rear suspension, I can buy the front suspension, I can buy the engine, and I can go step at a time. Do you have kind of a laundry list if I came to you and said, look, I can't write a check for this right now. I've got a 2-year plan to do this. Can you start here, and put together the components so I can just take the steps as I can take?
Absolutely. So we can sell you the whole kit, or we can do, within EV systems, you can kind of break them down into subsystems. Maverick and I are actually doing a seminar on this later today about these subsystems and how they all play together. But it's not uncommon for someone who has a limited budget, can't cut the check right away. Be like, okay, well, let's start with getting you the motor, and then that way you can start fabricating up mounts and figuring this out. And then when you're ready, come back to us and we'll get you set up with the next part, or we'll sell you a full kit and then we'll just ship it in pieces as you pay for it.
Okay.
So there's definitely, you don't have to be able to cut the check right away.
Yeah, and I just want to add to that on a quick shameless plug of come check out our session at 3 today. It's how to get your EV motors turning, and we're going to do it like it's a classroom. So it'll be a lot of fun. We brought whiteboards. There's going to be quizzes. It'll be a good time.
Where is it?
Yeah, our carry-ons were very
room.
heavy. We brought 40 Expo pens and a bunch of mini whiteboards.
Yeah.
And we're giving away stuff.
It'll be in this room, 3 o'clock today.
I think I'll definitely come back for that one. You mentioned, the safety aspect of doing this. From a shop standpoint, if I'm going to take on this project, other than fire extinguishers, is there something that I need to be aware of? Is there something I need to look out for just to make sure that we don't have an accident, we don't have a problem in the shop? Jake?
Yeah, there's a lot. And back to Kirk's point, we don't want to scare anybody because the exciting part of this is incredible. But as we introduce new technology, we got to be safe, and there is a lot. There's a lot to learn. And it does depend a little bit on the type of, of your product that you're using, as to kind of the level of safety. The higher up into actual racing motorsport, where cars are going to be on a track with other cars, there could be collisions, different things like that, where we're keeping, not just the driver safe, but people around the driver safe. There's different types of safety technology there. And, but there's some really simple, basic things, that can be done as people learn and educate themselves on those. And I don't know if it makes sense to get into them, but there are things like high voltage interlock loops, and there's isolation monitoring and different things that tell us, if the system is safe. And there's really intelligent components like what AEM has in their VCUs, where a lot of that logic is built in, and it tells you if the system is safe. And the system doesn't even close contactors to give you high voltage to the motors until all those safety checks are done. And so I think that's a really important thing to say is find some experts like guys at Legacy, or if you're doing something more end-to-end powertrain like with Hypercraft, we will be a partner in it, and we will help. The industry experts, the people that are working on the business side of this, will be a part of that.
Yeah, and I think there's also kind of two kinds of safety when doing a build. There's like procedural safety, like how you handle yourself around the technology, and then there's systematic safety, which is what Jake's referring to with like high voltage interlocks and things like that. So, I mean, you can come to Legacy EV and do a 1-week training, and we have all the components out on tables and toolboxes, and you get to wire them all together and practice understanding the procedural safety, and then actually observe the systematic safeties as well. So it's a great way for people to get their hands on these systems and understand how they work in a really safe environment. We chunk it up step by step, so nobody's getting involved in a procedure that they don't feel really equipped to handle, and now you get to go back to your own shop or your own garage and actually do the thing, but in your car.
And this is something you regularly do at your shop?
Yeah, we do them once a month. At our facility. They're a week long, 5 days. It's kind of like summer camp, honestly. We go and do dinner together at night, and like people end up being pen pals by the end of it, and people come from all over the country and world to participate. It's a lot of fun.
Yeah, the other thing I'll mention too is the conversion aspect of this, where the systems get really plug and play, and a lot of this is designed. These are the safest systems, right? Because so much has been figured out. The more you transition into motorsport and racing applications, that's where things are being much more invented, developed, and that's a different level of safety, systematically and procedurally. We're dealing with systems that are 800 volts now instead of 400 volts, and that provides a significant change in safety on the procedure and the system level.
So it's not like the 12-volt deal where you touch the wires together to see if they're hot?
No. Yeah, fireworks. Yeah, fireworks. We, all of us up here have blown things up, and just like an engine development, developer. Mike Thermos is an old friend of mine, a guy who owned or founded NOS, nitrous oxide systems, and they used to put 12 bullets. They said they'd have 12 engines set up to go on a dyno to figure out how to tune this engine back in the day. They'd blow up 12 engines, and there would be catastrophic failures. The end result was the guy in the shop could get a jet kit that was actually going to work and keep an engine together and give you a specific amount of power. So some of the things we're talking about, it's not just, hey, you should do this. Like, holy shit, you really need to do this, because we've experienced it and it wasn't good. So learn from our experiences and our failures. But this is about business opportunities as well. So on that side, you're going to have to invest in some safety equipment. There's some differences, and there's great videos that everyone's done just outlining that, from protection, personal protection, to what kind of fire extinguisher you get, the yellow bottle versus the red bottle in your shop. From a business component, there's another really cool part of this, and these guys might not like a lot of this because it's going to talk about salvage yards and salvaging drivetrains out of wrecked EVs. The Tesla is sort of the LS has become the LS. The Tesla Model S is sort of like the LS crate motor, where it's this drive unit inverter, very compact, very powerful. And there's companies out there that have some open source controls, so you can control the inverter controller board via that. AEM has a driver board that's done it. So it allows you to go to a salvage yard and salvage a drivetrain out of a vehicle for a substantially less, we're talking about 10 to 25% of the cost of a new drive unit. So it's a substantial savings there. Now, talking about building vehicles off of salvaged parts sounds insane. That's like, I'm going to go buy all my engines, my LSs out of a scrapyard. The fact of the matter is that the OEMs, because of the complexity of this and because of how things can get damaged in the event of something going sideways, there's a tremendous amount of strategy worked into the VCU at the OEM level. Meaning that if you're standing in a junkyard and you're looking at a Coyote or an LS, you can look at that engine that has 50,000 miles and you have to contemplate, was it overheated? Was it mechanically over-revved? Was it serviced well? Did the guy change the oil? Who knows what kind of fuel he put through this thing? And what else possibly might have happened? That's over there. So there's a lot of questions, which usually means tearing it down, checking it, and putting it back together. On an EV, you can look at an engine outside of a flood vehicle, or I'm sorry, a motor. Outside of a flood vehicle, you can look at it and you can say with a very, very high degree of certainty that there's absolutely nothing wrong with this motor because it's been so well protected throughout its entire life. So the only thing it's going to have on it is the miles that are on the Odo. So if you have a low mileage drive unit, you can take that, clean it up, and put it into another vehicle, provided you have the controls for it. So this is just another path on the conversion side. There's a lot of really bright people out there, and there's a lot of really bright people working on control systems that will again bring that cost barrier down, so your customers can enjoy these power drive units.
How much compatibility is there with controllers engine to engine? I mean, everybody knows if you get an LS, you know what transmission it'll bolt to, you know what you got to plug in. If you go buy this salvage yard engine, can you get an aftermarket controller plug and play? I legitimately don't know how much compatibility there is back and forth.
Yeah, so great question, Alan, thanks. The majority of the drive units the OEMs are providing are referred to as direct drives. So it's a motor attached to a little differential unit, and so you don't have a transmission interface. So the trans control sort of goes to the side. So you have a direct drive system. How do you drive that? With the higher volume drive units out there, the Nissan Leaf for a lower power conversion, the Tesla Model S base or performance drive, and the Model 3 all have either open source or some sort of manufacturer controls available that are somewhat plug and play. Okay. So these drive units are the motor and inverter combination. So the inverter takes the DC voltage, turns it to AC voltage. The challenge is that's where it stops. Now you've got your battery pack, your contactors. There's a whole bunch of other stuff, and if you just want to understand what the major devices are and how they communicate and how they have to be controlled, and understand so you understand what they are when you're looking at them. Like I said, Legacy this afternoon will lay that out for you. But there are no, outside of what GM has downstairs, there's no true full systems available unless you're doing it end-to-end like Hypercraft and a couple other companies are offering right now.
And I'll add to that too real quick that you can also get like the used OEM parts from Legacy EV. Now we have a Nissan Leaf package and a Tesla package that you can pick up, which will come with all the parts you need that would be missing out of the initial powertrain. And they come from certified refurbishers who are making sure that all the components are working well and that you're going to get a working unit where you're not like playing roulette by going to the salvage yard and being like, I hope that all the battery modules are good on this Tesla, because you can end up spending a lot of money trying to go track down new modules and balancing modules to get them at the same voltage, which we can talk about at 3 o'clock today.
Jake, most of what you do, the higher end stuff, is just, it's all brand new. You're not a guy that's going to go to put salvage stuff together to try to build somebody's race project, right?
We don't. So part of our company is now what used to be Stealth EV, and it does a very similar thing. But we're very much working, and we have a strong partnership with AEM to help bring some of these new products to market that are plug and play. We have a battery pack system that's modular, 10 kilowatt hours each, that can be series connected, and it's all plug and play. There's nothing to think about, and you can build 400 and 800 volt class systems in your battery pack in anywhere from 20 kilowatt hours up to over 100 kilowatt hours. So there are some things, and yes, it's brand new. These are all new cells. Internally, it's all something designed and engineered in house at Hypercraft. But it is coming to market as a plug and play turnkey solution. That can be safe in addition to some of the other great things. Now, there's so many reasons that we even as a company support the junkyard concept, because it is getting the technology more out there, more people have access to it, and as Kirk said, the costs are still pretty high to jump into something that's brand new and bespoke. But there's all kinds of great options right now, and at many different levels, all the way up to plug and play, but all the way down to where you're going to get much more involved in how to design and put that system together, and learn a lot more about that as you do it. So,
I can't help but think that from a hot rod standpoint, from your weekend car, so to speak, not necessarily your daily driver. Everybody puts something together, and then a year from now you want to upgrade something, you want to change something, as fast as the technology is going. If a customer comes into the shop, does an EV swap in one of these classics, 2 years down the road, 5 years down the road, there's going to be something to upgrade, right? There's going to be something, whether it's a better battery, whether it's that you can upgrade performance. So you would be in a position of not just a one-time customer, but getting a customer that's going to come back over time, because I don't know anybody that 5 years from now doesn't want their car to be a little bit faster, right?
Yeah. Yes. Yeah. Yeah. So here's the good thing for your customer base that's, let's say, on the EV conversion side. The one area that I believe is spinning the fastest with regard to development, being accelerated the hardest, is battery technology. So you can guarantee, I have news feeds. I probably have 12 different news feeds on battery technology alone. And every day somebody's reinvented something or some new chemistry that's going to give higher power density, lighter weight, and so on. So what that means is that we can say, just glance up to the horizon a little bit, say, what, batteries are going to get better. Here's the cool thing. They're DC. They're never going to be anything other than DC, meaning that the entire package that you put together, and let's just stick at 400 volts, it's a 400 volt system. It requires a 400 volt battery pack. As battery technology is enhanced, you might be able to get a bigger pack, a smaller pack, a lighter pack, whatever that might be. Those high voltage cables, it's a positive and a negative, going to that inverter, are still going to remain the same. So the battery side changes, the battery management is going to change a little bit, but the fact of the matter is that component is going to change for the customer and for us. So that's probably one of the biggest areas that I see, as far as changing over time. The other side of that is that we haven't talked, we talk about, EVs being cool performance vehicles, and there's a lot of performance there. Anyone who's looked at a dyno for an EV motor or EV vehicle, it looks like the dyno's broken because you have a tabletop. They say, 100% torque from, on demand, or zero RPM. Fact is, it takes a few RPM to develop torque, but the majority of the vehicles that anyone is building have a ton of torque pulled out of them out of the gate. Because if let's take the 2002 as an example, and you put 120 horsepower in it and all that torque, and if you're going 3 miles an hour and you put your foot in it, the tires are going to go to 100 miles an hour almost instantly. So there's a torque versus vehicle speed or rate of acceleration ramped in. So if someone wants more, you can give them more. But I don't work for AEMEV, it's what I know best. So our controller has map switching. So you can have 4 different power levels by touching a button. So if you're driving along, you want more, or if it's raining out, you want less, or your kid or the valet is going to drive you can put it in, we call it parking lot or pit mode. It'll only go 8-12 miles an hour, have really low torque settings. So there's all sorts of ways to offer an enhanced performance to the vehicle outside of a mechanical change, just via pedal mapping.
Maverick, did you want to add to that? You look like you're...
No, I didn't. I was just really engaged in what he was saying. I will say that I agree with batteries being a huge increase. It's even really cool to hear Jake talk about a 400 volt, 20 kilowatt hour pack, because Tesla 18650 modules have kind of been the battery module to use in the industry for a really long time. But to get up to 400 volts, you needed to use like 16. Now you're rocking an 80 to 100 kilowatt hour pack. And that just takes up a lot of space. And so it really limits what you can do with batteries and the footprint. So to be able to offer a 400 volt, 20 kilowatt hour pack is huge. And that's how quick the industry is growing. It's like there's new technologies coming out all the time right now, and it's super exciting to see.
Yeah, and what I would add too, kind of rehashing the battery conversation, is this is a vast oversimplification, but the power output that an EV can put out is determined by and large by 2 factors, just like raw power, and that is voltage and current. And much in the same way in an ICE vehicle, it's determined by how much air and how much fuel you can move through those pistons. And so when we talk about improvements in battery packs creating more power, it's not just about energy density not just about energy density or space savings, about power density. How much more current can those batteries put out for a continuous amount of time? How much more current can those put out without voltage sag? When you discharge a battery, the voltage drops. And so if we remember that, power output is determined by voltage and current, it's the product of those two numbers. When our voltage drops, now our power does. That's why a lot of Teslas, when you get on them right away, it's right there, but they suffer from voltage sag, typically I think 40 to 50 volts under full load. And so now they kind of die off. And so when we talk about why it's exciting that you can switch a 400 volt battery pack, that's a huge upgrade in performance because of Watt's law on some fundamental level.
So that's back to the C rating you were talking about, right?
Absolutely.
What can you do? What's the battery designed to do, Jake?
Yeah, just kind of along that line from a business side, and Kirk is touching on this. Every parallel that we have, or everything that we have with internal combustion, there is a parallel opportunity for electric, right? If it's upgrades, if it's complete bespoke systems, if it's performance tuning through electronic control systems, there is a parallel in EV to gas or any type of internal combustion. So I just kind of want to make that point that, it's possible somebody owns a Model 3, Tesla Model 3, and within a couple of years, they can bring it to a performance shop, and those performance shops will have the option to replace the whole battery pack with a DC power source that was more designed for performance or racing, and do a complete ground up, pedal map and performance tune on that car, send it out the door as a completely upgraded Model 3. So today, I think we can replace the steering wheel. But in a couple years, there's going to be some really cool offerings and some tools out there for performance shops to do some amazing things with, even production cars. So bespoke powertrain systems, turnkey conversion kits, performance upgrades, tuning opportunities. It's all going to be there. It's all coming, and it's coming really fast.
So obviously from a business standpoint, another revenue stream if you get into that, right? Instead of just we can take your classic and do the conversion, bring us your modern car, we can do the upgrade or the updates as well, right?
Yeah, true. And again, not having to look over your shoulder, wondering if the feds are going to show up. So I'm not a conspiracy theorist guy, but it's really awesome when you can build a vehicle and not worry about legislative and regulatory pressures or headwinds. So that's a big part of it as well.
From a classic conversion standpoint, other than obviously we're changing the power source and we're going to put battery packs in, we're going to make all that happen. What about the car itself? What would have to be done to the car itself? When you did the Bronco, what did you have to do to the Bronco? Was there anything other than just, obviously replacing the power source?
Yeah, well, it really varies by car. How many batteries are you putting in there? Is the weight distribution going to change? We've done trucks where we get now a 50-50 weight distribution, and there's not that much that has to be done to the vehicle. It depends on if you're maintaining a manual transmission. Like, you can maintain a manual trans, or you can do a transmission delete and do a gear reducer single speed straight to the rear end, or you can do a Tesla LDU, and now you've got true direct drive. So depending on what you're doing, a lot can change or not much. Like, we've done a Volkswagen Bug conversion, and you leave the manual trans, you made a Hyper 9, you do 5 Tesla modules, and now you're doing burnouts in first gear in a Volkswagen Bug, and everybody's like, how is a Bug doing a burnout? This is wild. With the Bronco, there was a lot of batteries in that thing, so we had to upgrade the suspension. We just did a newer F-150 that has a ton of batteries in the bed. We had to put airbags on the rear end to help support the weight. So it just depends. And that's where, being an automotive mechanic really lends itself to becoming an EV technician, because you understand the fundamentals of building vehicles. So there's a lot of debate in the industry right now on should we be training electricians to be EV techs, or should we be training automotive mechanics? And for anybody who's been involved in the industry, you can do both, but automotive techs know so much about cars. There's already such a good foundation. We can teach the fundamentals of electrical theory and build off that base knowledge. So long-winded answer to your question.
No, that was great.
Just want to add to that.
Please.
Yeah, so anyone familiar with the website Bring a Trailer? Yeah, me too. Addicted. So I've got filters on that, and I get my feed, and I'm I've had several Porsches throughout my life, and I had one of them was a Porsche 1970 911T, and it was a piece of shit. It had 6 one-barrel carburetors that were really challenging to keep tuned, and it was a drag. My girlfriend didn't like it. I liked it because I thought it was cool, but because it was a Porsche. So what's amazing to me today is I just saw one the other day sell for $73,000, which is mind-blowing to me. So we're talking about these vehicles being converted. The last thing in the world you want to do is have the opportunity to reduce the value of that car with modifying the chassis of the vehicle. So it falls back in the hands of the conversion facilities to make sure that as they're snapping components, the packs, the motor drive systems, they're using factory mounts. So it becomes bracket systems. So what this means in the end is that if I had my 1970 Porsche 911T today and I did my conversion, I could do it without upsetting the vehicle's original mounting or chassis and enjoy the car. And then if I want to put it on BAT, I can leave it as an EV, or I can swing all the OEM parts back into it if it's going to enhance the value. So it's my choice at that point. But the fact of the matter is that you don't want to upset the history of that vehicle, and you can do it, done well. There's a lot, I don't know if you're familiar with Moment Motors down in Texas. They do a phenomenal job. I've seen BMWs, 240Zs, all sorts of older Jags where they're doing these kits, but it's all in the fab. The motor drive systems are selected and engineered, but the fabrication done properly, you don't upset the value of the vehicle. So that's sort of a critical component as well, to me.
You mentioned the kits, and I believe, if I'm not mistaken, I read Hypertech. You can send me a complete kit as a shop, right? Somebody comes into me and says, I want to make that. You can send me a complete kit that is pretty close to bolt-in, or is it still going to require, depending on the vehicle, is it still going to require me to fabricate mounts and brackets and things, or how close is it to just pull the gas engine out, put the electric in?
Yeah, so Hypercraft's focus is to design and engineer the complete powertrain system end to end. But that's where we hand off or partner with the builder, the vehicle manufacturer, and it's something that we're in relationship with them. Picking places on the vehicle, to put all of these devices, and we can advise. But it's really the EV powertrain system, and we do most of or all of the harnessing, low voltage, high voltage harnessing for the system. So once the vehicle has everything mounted, then we go in and we help build the rest of it. So for us, it's very hands-on, but our systems are pretty bespoke, and we have systems up to 4 motors, so we can do a lot more with leveraging the performance benefits of EV if there's a desire for that. But we also have some pretty great, plug and play turnkey systems as well that are very easy to integrate, don't require modifications of the vehicle. So it's a wide range.
Is there any particular make, model, style that lends itself to an EV conversion, or anyone that you would kind of like, that's probably not something to get involved in?
I was gonna say, look, most cars are driven by some type of drive shaft. It is very, very easy to integrate an electric motor and keep the same drivetrain in the vehicle. Now that is not technically the most efficient way to leverage the benefits of an electric motor, because they are direct drive. The closer we can have them to the wheels, and when you get into multi-motor systems, front wheel or all-wheel drive or 4-motor systems, the drivetrains are completely redesigned, and there's a lot more modification to the vehicle required. We did a project with Dave Kindig, on a 53 Corvette using a roadster shop chassis, which is a dual motor rear drive that required very little modification to the chassis, but powered the rear wheels with 2 motors directly at the rear end. So there are some situations where you find it lends itself really good to an EV conversion. But a lot of times it's you either start really simple with 1 motor that integrates into the existing drivetrain, and that's pretty easy to do because these motors are really compact. But as you start to want to leverage more of the benefits and the efficiencies of EV, you start more, modifying more, and then I think it's less vehicle specific.
Yeah, and since this is a business like seminar too on the EV industry and future outlook, our model's not manufacturing. Our model is parts distribution. So we work with like 40 to we're getting close to 60 now installers around the world that take our systems and install them for the end user. And with that, these builders end up designing mounts and brackets that can be used for a C10 or a Bronco or a Mustang. And then they take those mounts and they work with us to now list them on our website, so they can go sell those. So now the next person that goes to do a C10 is like, oh, this shop in Phoenix built C10 mounts. I'll just grab those with my kit, and now I've got a kit that's mounted, ready to go. So we can kind of leverage the collective knowledge of these builders who are doing a lot of the legwork. And while I said earlier, like, if you're doing conversions now, you can probably consider yourself a pioneer. It's also been being done since like the 80s and 90s, even earlier. So like people in the room who have been involved in that for that long are like, I was a pioneer 30 years ago, how are there still pioneers? And it's the nice thing about being a pioneer now is the early pioneers figured a lot of stuff out that we don't have to figure out anymore, but you're still gonna turn heads when you go to a car show and people are gonna think, wow, I didn't know you could do this. And you get the benefit of 3 decades of experience before you and still getting to be a pioneer.
I'm guessing the communication's pretty open, right? You were talking about, the guy in Phoenix that did this. If the guy in Dallas is doing the same thing, he could reach out and go, hey, can you give me some pointers? Can you give me an idea here? Can you help me get past this roadblock?
Yeah, there's a mutual admiration and appreciation for the challenges. So there's a lot of teamwork involved. Right down to the code level. Did you guys do this, or what bracket, or what? But just circling back to the vehicle, if anyone, what I usually say, if someone says, I want to build a vehicle, what should I build? My response historically has been a pickup truck. It's just really easy platform. There's a full frame. There's a bed to put batteries in. It just makes it easy for you the first time to mount and put things throughout the vehicle. So it's just an easy platform to work off of. To bolt things to or fab to, and you're not worrying about disrupting a classic vehicle or dinging a quarter panel. And lift the bed off, and you've got sort of a clean slate. And you can either put an IRS, independent rear suspension package with a Tesla drive unit, because that whole cradle will fit up underneath a pickup truck with suspension, control arms, brakes, parking brake, everything. And then you have places throughout the vehicle to plant your battery packs. So that's a good platform, just planting a seat if anyone's thinking. Or if you guys guys and ladies own shops out there, everybody has that customer who's just game. Yeah, man, I want whatever it is, I want it. So if you have that customer and they're willing to participate and understand it's a learning curve for you as well, just to get going on it, I highly recommend it.
Awesome. We're about up against time here, and I know that everybody's got a lot more show to cover, but I just want to run through if there's any last thoughts, anything you want to add, Jake, anything we didn't touch on?
I guess the last thing I would say is that, look, especially from a business perspective, the motorsport racing community is uniquely qualified to take on the challenges of EV technology, right? I mean, I've been in so many shops. It's incredible how impressive these shops are, and everybody who works in this business and does things. So I would just jump in. I mean, there's so much to learn. There's so much to do. And I think this industry specifically can lead consumer perception around EV, do really creative, awesome, exciting things around performance, help redefine performance. And the more of it that we do, the better and stronger this industry gets. And so that's what I would encourage.
Thank you. Tim?
Yeah, I would say, at this point, I think it's pretty obvious that the EV revolution is here. It's not so much a question of if, but rather a question of when. And so we're at this spot where the pioneers have kind of laid a roadmap. We're at this crucial moment where you're not necessarily fighting giants. There's a ton of potential, and a ton of opportunity in this space. And I would encourage you to get in now, because if you're getting in 10 years from now, you're 10 years too late.
Yeah, obviously, anytime there's a new industry, a new emerging, getting in on the ground floor is a huge advantage.
Yeah, definitely. And I do think now is a really good time to get into the market. We're seeing with a lot of our builders, they go from maybe getting 1 request for an EV a month, maybe, to now like 50% of the requests they're getting are for EV, sometimes more. And now we've got shops that are like, this EV thing's cool. Like Jake said, it's got a steep learning curve, but once you understand it, it gets a lot simpler, and now they're only doing EV. And so getting in the market now, understanding it, and establishing your business as a company that is not afraid to take on a challenge, I think it's a great time to do it.
Yeah, everything they said. I just want to bring up one other point that we didn't talk about. Huff's vehicle's downstairs. It's a drag car. That's the first drag car to go over 200 miles an hour at a quarter mile. Something came up yesterday that I didn't know, which I thought was just absolutely mind-blowing. Anyone who's drag raced or road raced understands the cost of doing a single punch in a car, whether it's a session or a trip down the track in a fairly competitive vehicle like a 200-mile-an-hour car. His vehicle, the vehicle cost to make a pass in energy, 90 cents. Is that mind-blowing? And then at the end of it, he was saying, he said, so cool, because at the end, I just drive it back into the pits. He doesn't have to shut it down. There's not 6 people pushing the car, with a locked diff. It's just absolutely mind-blowing. But I just wanted to share that fact, because I think if you tell your customers that, like, hey, dude, under $1 a pass. Are you kidding me? Yeah. So I just thought that fascinating. I wanted to share it. So in the end, I say, like they're saying, look, we're at the beginning of a market that is coming. I guarantee it. And I encourage you to get involved in any way, shape, or form. I'm available for questions afterward. These guys have amazing information on their website. Although I'm not part of the AEM EV team, our YouTube channel has all sorts of informational, from safety to systems integration to understanding what the primary components are. So I encourage you to start watching some YouTubes and ask us questions to figure out if it fits for you.
Thank you. I appreciate everybody coming. There's a QR code on the back of the chairs if you guys want to scan that, and you can give us a report card, if you will, on the seminar. But we really appreciate everybody coming, taking time out of your day. Thank you to all of you guys who came up here to share some information. And as I said, everybody has any questions afterwards, please come up and feel free. But thank you guys for coming. Really appreciate everybody's time. Thank you.